Okay, welcome to another Ginger Mathematician video. So I know the exams are coming up reasonably soon, so I thought I'd continue with my paper 4, which I started about a year ago. So let's try and take this up again, and I'm going to go through the questions from the June 2015 paper 4, open brackets 3. So we're going to go from question 8 onwards and just keep going through those questions. I found a few recommendations from people that want me to go through a paper 4, so that's what I'm going to do. Before I start, I'm going to say please like, please subscribe. It does help the YouTube channel grow. I really do appreciate it. So let's continue on. So let's see what question 8 has in store. And we have a cumulative frequency question. So 100 light bulbs are tested. Now the length of life in thousands, that will become more important a bit later on, worth underlining the key information, and we're given the table here, a grouped frequency table, and we need to find the estimate of the mean. Okay, in order to do that, we need to find, first of all, the midpoints of our categories of our classes here. So I'm going to write midpoint, and I'm going to find the midpoint of each of these classes. Whenever you see an estimate of the mean question, you need to find the midpoint. So midpoint between 4 and 5 is 4.5. And next one is 5.5. You could also do this by doing 6 plus 5, which is 11, divided by 2, gives you 5.5. And watch out for the trick at the end. Let's see, you fall for it at home. Hopefully not. Because with this one here, between 10 and 12, of course, the answer is 11, not 10.5. Don't be lazy in the test. Do focus on every single part. Now, most teachers will tell you at this point, okay, we do midpoint times frequency, add them together, divide them by 100, and we have our answer. However, the 0607 course wants you to use your graphical display calculator, which I'm going to show you how to do now. Okay? Now, we're not doing trigonometry today. We are definitely not. Instead, we are looking at my GDC, which is right here. So have your GDC ready, so on and ready to go. We're going to go to the lists and spreadsheet function. Works very similar to Excel. We're going to label M for midpoint, and we're going to label F for frequency. Keep the letters simple. Keep it simple. It's my approach generally with mathematics. And we're going to type in all the midpoints, which works exactly the same way as Excel does. 8.5, 9.5, 11. And then we type in the rest. So we've got 8, we have 21, we've got 31, we have 23, we've got 10 and 5 and 2. Right, and we've got everything in our table. Now, this is a useful thing to know for IB later on as well as iGCSE. We go to menu, we go to statistics, we go to stat calculations. And because we have a frequency table, we want one variable statistics. We've got number of lists 1. Our X1 list is going to be those midpoints that we've selected. F for frequency, that's why I've used these letters. So frequency makes sense to go with F. We press the OK button and boom, you'll see the very first thing here, which is X bar, which is the sample mean. If you want to look at IB, feel free to look at my videos. And that's going to be 6.8. So all we have to do is write down the answer of 6.8. Now, to get the method mark, you do need to write down the midpoints. So don't think you can do everything on your GDC and then just write down the answer. You do need to show method. So that is important. Okay, so estimate of mean, common question on a paper 4. You do need to know how to do it. Your GDC will save you a lot of time. See how long that took me, rather than having to work out everything individually. It is 2 marks. It wants you to be aware you can use your GDC. Right, let's continue. So we're going on to question B. So we need to draw a cumulative frequency curve for the length of life of light bulbs. Okay, so I'm going to delete the midpoints because I don't want to get confused with what we've done so far. Okay, and as soon as it says cumulative frequency, the phrase that should be in your mind is a running total. So as soon as you see cumulative frequency, it means running total. In fact, in German, it's Summenhäufigkeit, which literally means Summen, so the sum of the Häufigkeit, Möglichkeiten, which is the frequencies. So German is very literal with this. In English, we say cumulative frequency. So we do a running total. What does that mean? Well, this is going to be 8. Then we do 8 plus 21, that's 29. 29 plus 31 is equal to 60. 60 plus 23 is equal to 83. 83 plus 10 is equal to 93. 93 plus 5 is 98. And our final number is 100. This last number should always be the same as our total. If it isn't, and I recorded this the first time, it was 99. So make sure you always check that's 100, then you can correct what you've done. The second thing to remember about cumulative frequency curves is when you plot this on your graph, you are plotting the right-hand side against this. So when we plot this, it'll be 5, 8, 6, 29, 7, 60, 8, 83, 9, 93, 10, 98, and 12, 100. Two things to remember: cumulative frequency, running total. Second thing, always plot on the right-hand side of the interval. Okay, so I think I've got all the information here ready. So I'm going to have a go at drawing this on a computer, which is much more difficult than in real life. So we have 5 and 8. So apologies if it's not quite correct. I'm going to do my very best here. So we've got 5 and 8. We have 6 and 29. So we've got 6. My eyes, I'm sure, are going to go dizzy. 6 and 29, there we are. And 7 and 60. Definitely going dizzy at this point. And I think it's there. I don't think I've quite got it there. Okay. 8 and 83. You might find my answers will differ slightly to the mark scheme because it's not quite exactly where it should be. Again, apologies for that. I think that's correct. My eyesight is going here. 9 and 93. 9 and 93, which I think is there. And 10 and 98, which is almost up to the top. And that's going to be here. And then the last one, 12 and 100. So we need to draw our curve. Now, again, this is even more difficult to do on a computer, but I'll do my very best. Notice this is out of 5 marks. There's something I want to highlight here. So you do get a lot of marks for doing this accurately. Yeah? So plotting to the right-hand side of your interval, making sure it's a smooth curve, making sure the points are plotted correctly. Make sure you do these things. Now I'm going to go from here, strictly speaking. You could also go from here as well. Different teachers teach it differently. I'm going to go right from the bottom, though it makes no difference for the subsequent questions. So here we go. Let's see how I get on. Here we go, here we go, here we go, here we go. Ooh, it doesn't look too bad, considering this is a computer. Okay, I've got a little bit too far upwards, but I think that's not too bad. Okay, 5 marks for that, and okay, there is quite a bit of working out, but it's all about being accurate. Okay, in terms of conceptual difficulty, this is not too bad. Right, and let's look at the last part of the question. So it wants us to work out an estimate for the number of light bulbs that lasted longer than 8,500 hours. Now I highlighted this earlier, it's in lengths of thousands of hours, so we're actually looking not for 8,500 here, but 8.5, because it's in thousands of hours. So we go to our graph, we're going to find 8.5 on our x-axis, which I think is, I'm looking for the halfway point, 1, 2, 3, 4, 5. I think it's this line here. We go all the way up. Now I have no ruler. Make sure in the exam you've got a ruler. So just make sure you're doing this absolutely as accurately as you can. I'm here. Now I think I'm going to disagree with the answer slightly, because I kind of know what the answer is. Yeah, I'm going to be like 1 out here. So the answer says it's going to be 10. Notice here I've made 89. So my answer, because remember we're looking for longer, go back to the question, longer than 8,500 hours. So we need this section here. So the difference between 89 and 100 is 11. Okay, so our answer is going to be 11. And we'll talk about the answers when we come to look at the mark scheme. The interquartile range, well, the interquartile range is calculated by upper quartile minus lower quartile. And what that means in real English is 75% of the data minus 25% of the data. And luckily, or maybe it wasn't luck, we've got out of 100. So 75% of 100 is 75. Yeah, so it's going to be easier to read off. So to go through the process, so the upper quartile is 75% of the data. So you do the same process we did before. I'm going to be curious how accurate I am, because this is pretty tricky to do. See, I'm going between two boxes. It's probably not a good sign. And then we do 25% of the data. So we go here, we hit our graph, and when we go downwards. Okay, so let's see what I get here. So 1, 2, 3, 4, 6, 7. Yeah, is that 5.8? Okay, so a lower quartile 5.8, and let's look at this one. So 1, 2, 3, 4, 5, 7.5. So with my graph, I think it's 7.5 minus 5.8. So let's write that down. And that will be equal to 1.7. So I say the interquartile range is going to be equal to 1.7 hours. Be interesting to see how the mark scheme goes there. Okay, so it's gone between 1600 and 1900. Okay, strictly speaking, I should be writing instead that it's actually going to be 1700 hours because it's done in thousands, so it should be 1700. And actually I get an answer right in between the range, so that is actually pretty good considering I did that on the computer. C part I, they got 10 rather than 11, but notice they do follow through, so it all depends on your curve. So generally they're pretty reasonable at iGCSE, so they want to see you've got the correct approach. 6.8 for the estimate, the mean, and then the 5 marks, which the descriptions are given here. Now, what I've included in this is also the examiner's report, which is useful for you to see which question discriminates between good candidates and great candidates. And I'm going to talk about that now. So for question 8A, as I already pointed out, many students did not use their calculator to do this. I highly recommend you get used to using your GDC to do these kind of questions. They will save you time, you see. Okay, usually by doing a lot of working, we want to avoid that. Generally, cumulative frequency curve is well drawn. Notice many people made the mistake of using the mid values. Please avoid that. And then usually the other questions were done correctly. Okay, so the discriminator, I use this word quite often with this question, is making sure you plot to the right hand side of your class width. Okay, that's where the biggest mistake is made on this question. Okay, let's continue. So this is a pretty tough question. This is question 9. So we're going to look at some similarity first of all. And we've got two similar triangles, EAB and ECD. What the word similar means in this case is that they're in the same proportion. Okay, so imagine one is an enlargement of the other. And we need to show that EC is equal to 120 centimeters. So what that is the entire length of this line is equal to 120 centimeters. That's what we're looking to show. First of all, notice we've got two corresponding sides here. So we've actually got this side here, 15, and then we've got this side, 20. So I teach it slightly differently maybe to other teachers, and the mark scheme is also different. The way I do it is by working out the scale factor, which I generalize as big divided by small. So you get 20 over 15. Okay, which if you wanted to, you could simplify down, of course. If you divide by 5 top and bottom, you get 4 over 3. Okay, please avoid decimals. Decimals will make your life a little bit more difficult. So that's our length scale factor here. So we've got 4 over 3. What we need to do now is use that to then work out this missing length. So imagine I don't know this length. So if I wipe this out with the eraser, imagine I call this blue length that I highlighted earlier x. Yeah. So this length here, EC. Then the entire length of the line is equal to x plus 40. Yeah. So if this length is x, then to go from A to E, we just need to add 40 to x. Okay. Now notice these are the corresponding lines of our small triangle and big triangle. So what we're asking ourselves is, okay, if I take x, our smaller triangle, I times it by 4/3, our scale factor, I should then get to my long length, which is x plus 40. And this actually gives us a reasonably straightforward equation to solve. So this times together, we write this in good algebra as 4/3 x. And this is actually a pretty straightforward equation. Okay, we minus x from both sides, like so. So 4/3 x minus x, this is a 1x, so we get 1/3 x. Remember, 1 is the same as 3/3. 1/3 x, well, these two things cancel, so we get 40. And what's the opposite of dividing by 3? Well, we times by 3. Most of you can see the answer here at this point. This cancels here. And we're left with x equals 120, which is good because that's what the answer should be, because that's what it says there. I've noticed many teachers don't teach it that way, but I think that's probably a more intuitive way than doing ratios of sides. I don't know. It's up to you how you want to interpret that question. Okay, we'll see the mark scheme at the end. Now, once we know that's 120, we need to work out the following things. So we need to work out ED and DB. So let's highlight what ED looks like. It's this length here. This one. And if we think about it, we've actually got a right-angled triangle. Yeah. So we are looking for ED, aren't we? Checking. Yeah, ED. Okay. So let's just take that triangle. So let's draw it separately. So essentially what I have here, the triangle where I don't know this. I know this is 120 from what we just did, and we know this is 15. So essentially, we can use Pythagoras on this question, just a straightforward Pythagoras question. So let me draw it onto this slide. This is 120, this is 15, this is x, and so Pythagoras says that x squared is equal to 120 squared plus 15 squared, and so x is equal to the square root of those two things. Notice I'm writing the minimum of working, but enough to guarantee me all the marks here. And this is where just use your GBC. So we go on to a normal scratch pad, which I'm sure you're familiar with, and we go control 120 squared, so use the square button, plus 15 squared, getting our answer here of 120.93. Again, we're going to round to 3SF, but we need to write down decimals first. And to 3 significant figures, which is generally expected, it's 121 centimeters. Okay, all good. Let's try and go back to a black pen. There we are. There's my black pen. And now we need to find dB, so let's have a look at dB and where that is. So dB is this length here. Okay, I think the most straightforward way, because we've already got this length here, we already know dE, we can use Pythagoras to work out the entire length of the line. I'm really having fun with my colours here. We can use Pythagoras to work out the entire length of the line with 20, and this is 160. And then take one away from the other to work out the short length. So let me go on to the next slide and show you what I mean. So this was 20, this was 160. We've already worked out this part. So this was 121. So we just use Pythagoras for the entire length. So if we call the entire length, say some y, then y is equal to the square root of 160 squared plus 20 squared. Okay, and then to work out this length, let's call that s. So s is going to be y minus that 120.93 from before. And I will just skip to the answer at this point. So if you do that calculation, we then get 40.3. 3 significant figures. Okay, so the way I do part 3, again, slightly different to the mark scheme. I think they recommend use ratio similar sides, but I just use Pythagoras twice and then take one away from the other. Look for the most straightforward ways of being able to answer the question. Okay, and now the next part I do like. It's hard, certainly I can see this is the AA star material, but it really does test your understanding of similarity and your knowledge of volume of shapes. So the diagram shows an open waste paper bin made from metal. Now this is actually important words that we'll talk about in the second part of the question. Open waste paper bin, so this is hollow, so to speak, so only this circle exists. The radius of the circle top is 20 centimeters, radius of the bottom is 15, perpendicular height of the bin is 40, and using part A, notice these lengths 40, 20, 15, these all correspond to this diagram here. Yeah, so notice that, we're going to use that later on. So, using answers in part A, calculate the volume of the waste paper bin. Now this shape is called a frustum. Hopefully I'm pronouncing it right. Frustum. Frustrating to work out anyway. And the way you work out a frustum is to think, if I extend these lines, now I'm going to kind of go over the question here, but just to show the point, essentially you're going to make a cone, yeah, a very big cone. So if you take the entire cone, okay, that's the entire shape including this bit. So the way to work out a frustum is to work out the, in this case, volume of the big cone and then minus the area, or the volume, sorry, of the smaller cone. Okay. Now, this is where you need to use your formula sheet, so let me write this up here. The volume of a cone is equal to 1/3 pi r squared h. This is on your formula sheet, don't worry. You do not need to remember this. It's absolutely fine. So, to work out the volume of this, we do the volume of the whole shape. We take the volume of the bigger cone, which is 1/3 times pi times, now our radius is 20. Now you're probably thinking at this point, I don't really know the height. I don't know the perpendicular height of this. But if we think about it, we actually do, because we go back to the question we looked at before. Yeah, so this is the perpendicular height, remember? So the entire length of the line is the perpendicular height, which in this case is 160. We used it before, 120 plus 40 is 160. So this is where you're using your answers from part A. So actually we do have the entire perpendicular height is 160. And now we minus the smaller cone. So we get 1/3 times pi times 15 squared times this perpendicular height. Again, we've also worked that out as well. That was actually given to us right at the start. It was 120. It's this length here. So we need to type in 120. Okay. And we do this, and this is where we're going to type this all into our calculator. So watch carefully, just need to be very careful as we do it. So we're going to put this in brackets. So we got control 1/3 times pi times 20 squared times 160 minus, open brackets, again we want fraction, control divide, 1/3 times pi times 15 squared times 120. Very important, yeah, we're using the answers from part A. And if we put that all into our calculator, we get the answer of 38,746.3. So always we're going to write down a few decimal places and then round to 3SF. So the 3SF is going to be 38,700, like so. Okay, there you are, which is the answer right here. Okay, and the very last part, which is the really tricky part, but we just have to think about this quite carefully, is now we need the area of metal needed to make the bin. Okay, so we need to think about exactly how we are going to work that out, the area of metal needed to make the bin. So just to remind you, okay, we've got the circle at the bottom that does exist. We've got then the curved surface area, which we'll need to work out as well. And then remember the top is empty, so we don't actually have a circle here. So give yourself a minute or so, have a think about it. How would you go about working that out? Okay, well, it's going to be a very similar way to how we did it before. So we're going to find the curved surface area of the larger cone, and then we're going to take away the surface area of the smaller cone, yeah, in the same way we did it before. Now, the thing is, however, the formula for the curved surface area of a cone is equal to pi RL, okay, where L is that diagonal length. So if I draw a cone, for example, okay, got pi r, and L is this length here. And at first sight, we don't actually have that length. Yeah, we don't actually have the length needed in order to work it out. But then we think, actually, we've already worked this out. We worked this out in the previous question here. We've already worked out that green length, okay, which was part 2, that 120.933. And we've already worked out this purple length here as well, which was using Pythagoras. So we actually do have these lengths. So let's put this all together so we can actually work this out. So let's put it all together. So let's start with the curved surface area of the frustum. Always forget if there's an R in there. Someone maybe can correct me in the comments. So we're going to do pi RL of the bigger one. So that's going to be pi times 20 times L, and L was this calculation here. So I am going to round. Now normally I would say not to round this, but just to show you exactly what's going on here, we actually do need to work out the length of the entire line. So we want EB, so we want this one here. I don't actually have a value for that, so I'm going to write it as this. So that's the curved surface area of the larger one. Then we're going to minus the surface area of the smaller one. So that was pi times 15 times then the diagonal length. So let's go back. I think it was it ED? It was ED, so it's this one here. So I'm going to try and avoid rounding errors as long as I can record everything. That should be a time, plus 15. So this calculation works out the curved surface area of the frustum. So this part here. Okay, and what we need to do now is add in this extra circle at the bottom. Okay, so this is the bottom of the waste paper bin. So we need to add in a pi times 15 squared, the area of the circle. So go back, plus 15 squared. And at this point, I'm going to put this all into my calculator. So this is all about being very accurate here, making sure we've got everything written correctly. So we go brackets. Let's see how this goes. Pi times 20 times, I'm going to open another bracket, so I'm going to put a square root in. You don't have to do this all in one step, but it's good to get used to being able to do this in one step. 20 squared, we're going to close that bracket, and I'm going to close that bracket again. Making sure everything is as it should be brackets wise, good, and then minus, we'll do a similar calculation now. Pi 15 times, open brackets, square root, 120 squared plus 15 squared, bracket, brackets, plus, and then we want this part now, so we've got pi times 15 squared, the bottom part of it. And this is where we hope everything works out. It's the correct answer, which it is. Good. That should be exactly as it is. 5,139. Okay, in fact, I think my answer is more accurate from theirs because they've rounded too early. So we've got 5,000. As you can see, the answer was acceptable. 5,139.3. Dot, 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 dot. And then that gives us the answer of 5,139. Which, as you can see, falls within the range of acceptable answers, yeah? So it doesn't matter, sometimes to a certain degree, it doesn't matter in terms of the rounding, as long as it lies within the range that they expect. Okay, so you get 4 marks for that. Notice, I haven't really written too much working there, but it's very condensed, yeah? This is the curved surface area of the large frustum. This is the curved surface area of the small frustum. We take one away from the other, and then we don't forget, of course, to add in the base circle as well. I'll put the mark scheme up on the board so you can have a look. It's been done slightly differently, some of these questions, particularly part 3 and part 1. I've done it a little bit differently. Maybe you find it easier, maybe not. Okay, but you can see you don't need to write lots of working, but it needs to be clear, it needs to be obvious what you are doing to the examiner. And before I finish this video, I'm just going to look at the examiner's report. So the similar triangle situation that we encountered here is actually one of the most challenging questions on the paper, which in some ways I find a bit surprising. There are other harder topics, but it's often a topic like, in terms of my pupils, I've taught them in year 10, but then I haven't had a chance to really go through it. So it's something that gets easily forgotten. So question AI was actually quite badly answered, even though it was the first part. Part 2 was Pythagoras, which is good. Problem with getting A part I incorrect, well, you still got that value to work with, but it probably has an effect on your performance in part 3, because you don't see the similar idea. And a lot of people forgot about A to answer out B as well. Okay, so they forgot they could actually transfer their knowledge from A to B. And with the International Mathematics course, is a little bit on the non-linear side, unlike some of the other iGCSE courses. You do need to actually look through the previous question. The investigation paper, paper 6, is quite like that as well, where you have to use previous calculations to use in subsequent calculations. However, most people found the volume of Frustum. That's sort of standard working out of the shapes. That's very, very good. And as we can see, that favourite word, discriminator, the surface area question was quite hard because many pupils did not realise to actually use the sloping heights from before. And as I pointed out, the area of the circular base was often omitted. It wasn't there. So this is a good question. If you want to get those A and A star grades, you need to be getting these questions right. Yeah. So this is an area, if you're looking for those higher grades, really to focus on. Okay, so you can see these questions are quite in-depth. I've only got through 2 questions, but they are important questions to boost your understanding of the iGCSE course. Please like, please subscribe as always, and hope to see you on the next video. Bye-bye for now.